The Pacific Ocean is vast and powerful, stretching over 63 million square miles. It is the largest and deepest of Earth's oceanic divisions, covering more than 30% of the planet's surface. Its currents and temperatures influence weather patterns across the globe, affecting everything from tropical storms to the monsoons in Asia, and even the jet streams that guide weather systems in North America and Europe. One such phenomenon is La Niña, a climate pattern marked by cooler-than-average sea surface temperatures in the central and eastern equatorial Pacific Ocean. This cooling effect can last for several months, sometimes even years, and has significant impacts on global weather. Imagine the Pacific Ocean as a giant swimming pool. In this vast pool, the water is constantly moving, driven by winds and currents. Normally, warm water piles up in the western Pacific, while cooler water rises in the east, driven by prevailing winds. This creates a temperature gradient that is crucial for maintaining the ocean's balance. This temperature difference across the ocean is essential for the distribution of heat and energy around the planet. La Niña, however, disrupts this balance. The usual flow of warm and cold water is altered, leading to significant changes in the ocean's temperature structure. During La Niña, the trade winds strengthen, pushing warm water westward, and allowing cold water to well up in the east. This process, known as upwelling, brings nutrient-rich waters to the surface, impacting marine life and fisheries. This intensifies the temperature difference across the Pacific, creating a more pronounced thermal gradient that can influence weather patterns far beyond the ocean itself. The consequences of this seemingly subtle change are far-reaching, influencing weather patterns across the globe, particularly in North America. It can lead to wetter conditions in the Pacific Northwest, drier weather in the Southwest, and more intense hurricane seasons in the Atlantic. La Niña is part of a natural cycle known as the El Niño-Southern Oscillation, or ENSO. This cycle alternates between the warming phase, El Niño, and the cooling phase, La Niña, each bringing its own set of climatic impacts. Understanding La Niña is crucial for predicting and preparing for its potential impacts on our weather, agriculture, and ecosystems. By studying these patterns, meteorologists can provide better forecasts, helping farmers plan their crops and communities prepare for extreme weather events. La Niña's impact on North American winter temperatures is like a continental seesaw, creating a dramatic contrast between the northern and southern regions. The southern United States tends to experience warmer and drier conditions, often leading to droughts and water shortages in states like Texas and Arizona. People in these areas might find themselves enjoying milder winters, wearing light jackets instead of heavy coats. In stark contrast, the northern United States and Canada brace for colder and snowier winters. Heavy snowstorms become more frequent, and residents often find themselves shoveling snow and dealing with icy conditions. This temperature disparity is driven by the altered jet stream, a fast-flowing air current that guides weather systems across the continent. The jet stream's position and strength are crucial in determining the weather patterns we experience. La Niña shifts the jet stream northward, allowing frigid Arctic air to plunge southward into Canada and the northern United States. This results in colder temperatures and increased snowfall in these regions. Meanwhile, the southern United States often experiences milder winters with less precipitation. This can lead to dry, barren fields and a lack of necessary moisture for agriculture. This is because the southward shift of the jet stream allows warm, dry air to dominate the region. Clear skies and pleasant weather become more common, making it an ideal time for outdoor activities. The contrast in temperatures across North America during La Niña highlights the interconnectedness of Earth's climate system. The weather we experience is a direct result of complex interactions between various atmospheric and oceanic factors. La Niña's influence on temperature is a reminder that even seemingly distant changes in the Pacific Ocean can have a profound impact on our daily lives. Understanding these patterns helps us better prepare for the weather extremes that come with them. La Niña's effects on precipitation are just as dramatic as its influence on temperature. The northward shift of the jet stream during La Niña alters precipitation patterns, leading to wetter conditions in some regions and drier conditions in others. The Pacific Northwest and the Ohio Valley typically experience wetter-than-average winters during La Niña. The shifted jet stream brings in more moisture from the Pacific Ocean, leading to increased rainfall and snowfall. In contrast, the southwestern United States often faces drier conditions. The lack of moisture-laden storms leads to drought concerns in this already arid region. La Niña's impact on precipitation underscores the importance of understanding and adapting to the variability of our planet's climate system. Section 4. Regional Variations. A closer look at La Niña's effects. While La Niña's general impacts on North America are relatively consistent, regional variations add significant complexity to the equation. Factors such as topography, proximity to large bodies of water, and elevation influence how La Niña manifests in specific areas. For example, the Pacific Northwest's mountainous terrain enhances precipitation during La Niña, leading to heavy snowfall in the Cascade Range and significant rainfall in the lowlands. The Great Lakes region often experiences increased lake effect snow due to the combination of cold air masses from the north and relatively warm lake waters. Understanding these regional nuances is crucial for accurate weather forecasting and effective adaptation strategies to changing weather patterns. Section 5. The Wildcards, Arctic Oscillation and Storm Tracks. In this section, we delve into the unpredictable elements that can significantly influence winter weather patterns across North America. La Niña doesn't act alone in shaping North American winters. It interacts with other climatic factors, creating a complex web of influences. Other climate patterns, such as the Arctic Oscillation or AO and variations in storm tracks, can either amplify or mitigate La Niña's effects. These interactions can lead to a wide range of weather outcomes, making forecasting a challenging task. The AO refers to the atmospheric circulation pattern over the Arctic. It plays a crucial role in determining the distribution of cold air masses. When the AO is in its positive phase, it tends to confine cold air to the Arctic. This means milder winter conditions for regions further south. However, a negative AO allows frigid air to spill southward, potentially exacerbating La Niña's cooling effects in Canada and the northern United States. This can lead to more severe winter weather, including intense cold snaps and heavy snowfall. Storm tracks, the paths that storms typically follow, can also be influenced by La Niña. These tracks determine where and how often storms will occur. A northward shift in the jet stream can alter storm tracks, bringing more storms to the Pacific Northwest and potentially increasing the risk of nor'easters along the East Coast. This shift can result in significant weather events, impacting millions of people and causing disruptions in daily life. Section 6. The unpredictable nature of La Niña's influence. While La Niña provides a general framework for understanding potential winter weather patterns, its impact can vary significantly from year to year. The strength of La Niña, the timing of its development, and interactions with other climate patterns all contribute to this variability. Some La Niña events are strong and long-lasting, while others are weak and short-lived. The timing of La Niña's development can also influence its impact. La Niña events that develop early in the fall tend to have a greater impact on winter weather than those that emerge later in the season. The complex interplay of these factors makes it challenging to predict the precise impacts of La Niña on winter weather with absolute certainty. Section 7. Conclusion. Embracing the uncertainty of La Niña winters. La Niña is a powerful reminder of the interconnectedness of Earth's climate system and the inherent uncertainty in predicting its behavior. While La Niña provides valuable insights into potential winter weather patterns, its influence is not absolute and can vary significantly from year to year. Understanding La Niña's potential impacts is crucial for preparing for a range of winter weather scenarios. From farmers planting their crops to city officials preparing for snowstorms, anticipating La Niña's influence can help mitigate risks and enhance resilience. As we continue to unravel the complexities of Earth's climate system, we gain a deeper appreciation for the delicate balance of forces that shape our planet's weather and our lives.